streamlined. Basically, it's an automatic process. It's just like conversion of the units and some geolocation. From level 1 to level 2, it depends on what you're deriving from those level 1 products. I mean, it doesn't necessarily happen at NASA. Sometimes other people propose projects like that. But I guess that depends on a level 2 product. But level 0 to 1 is more streamlined. Jennifer, do you have any comments on that?
So can you hear me? Can you hear me?
Yeah.
All right. So I think there is more than that, but within the NASA open science policy, and we're trying to sort of all.
I know about my food. I study.
The email is there.
Yeah, you can email us the questions you have. Thank you. Yeah. We're right on time. Like 30 seconds. Yes. Thank you so much. Thank you, Jennifer. And thank you.
Hello?
Okay.
Excuse me, can you please take this up while you're talking? Thank you. Can we please have some silence, and we'd like to start with the next speaker as soon as possible. Are you ready? There are Seneviratne. All right. I'm very happy to introduce Oshani, the Seneviratne. I hope I said it correctly. And it's the food knowledge graph reimagined, FoodKG Reimagined. Oshani, please go ahead.
All right, welcome everybody. So from games to climate change to food and right before lunch, I guess right on cue. Okay, so by participating in this session, I have listed several talk objectives. So first, I will talk about the motivation of this work. So there's a lot of complexity in constructing a knowledge graph of food items. And then I will talk about the stuff we did to actually construct the knowledge graph. And then I'll talk about a bunch of applications. And unsurprisingly, the application is food recommendation, food substitutions, things like that. And really the point of this talk is how we can extend this FoodKG and applications. And just like previous talks, we are exploring things like Retrieval-Augmented Generation. Talk about that with respect to both the inference and also in extend the FoodKG. And then I'll also talk about quality assurance of the various food items we have with incentive mechanisms. So I want to give a big shout out to the collaborators behind this project. So this work actually started with this IBM RPI collaborative project called Health Empowerment Through Analytics, Learning, and Semantics. If you want to find more information about this project, you can go to that website, which has more information other than the FoodKG. And Deborah McGuinness was a co-PI on that project. She's here in the audience. And more recently, we have started a collaboration with the UC Irvine. They have Future Health Institute, and they have this open framework called Open Computational Health Agents, or OpenSHA. And we have some collaborations from that organization as well. Okay, so the motivation, I guess it's kind of a no-brainer. So there's this huge problem of chronic health conditions, and if you see the woman there, just like me, she's leaning towards unhealthy food items, and she has fruits on the other side. And basically, evidence-based nutrition recommendations are not easily integrated into the dietary applications that use, and more importantly, they're not personalized to our, specific, health conditions, our preferences, things like that. So, and another motivation is like, let's say you open your fridge and have, chicken, you have onion and garlic, and you're in the mood for some Indian dishes. So you have these, constraints, and if you Google, what Indian dish can I make with chicken, onion, and garlic, you will be presented with, a bunch of these options. And if you look at these options, like, maybe some of them are the same recipe. It's not that easy to kind of figure out these are the, same recipe. You have to do a little bit of research. And maybe, this hungry Jennifer is on this specific low-fat, low-carb diet and is also lactose intolerant. And if these recipes are suitable for her, like she has to again, do a lot of reading to figure that out. So knowledge graphs could actually help that problem because you can, have all this, integrated, view into the data. But it's all good. Knowledge graphs are good, but there's some challenges in kind of combining all these things together, because so at the very high level you have recipes, and recipes have ingredients, and each of these ingredients have different nutrients, and we also have dietary guidelines. And then on top of that, we have these personal, human factors, personal preferences, allergies, and things of that nature. And so we want to integrate all these things so that eventual users do not have to spend a lot of time to figure out what they can eat. And at the same time, we want to maintain the provenance of the recipes that they are looking at, right? So that's the biggest problem with recent LLMs, right? So you can get the same information, but you don't know where this recipe is coming from. So in our food knowledge graph, we are maintaining the provenance information. Right, so we have worked to build this cohesive food knowledge graph, and it brings together recipes, nutrients, and other food vocabularies. It links to existing ontologies and vocabularies. It's straightforward to use, it's modular, so anybody can extend this resource. And in fact, so we published this paper in 2019. So far, I personally know of at least 20 different projects that are using the FoodKG, and we have over 200 publications. So this is a very good resource, and people are using that. And I encourage everybody in the audience to, reuse this resource. And more importantly, we maintain provenance for every assertion. So we are combining different data sources. So when we combine these different data sources, it's very easy to lose where things are coming from. But in our knowledge graph, we actually maintain that provenance. So that's a very important goal of our work. So let me talk about the data sources. So we have, at the last count, we had close to 1 billion triples. And this includes all the provenance information, things of that. But if you look at it, the number of recipes is a little over 1 million. And the recipes actually came from this data source called Recipe1M. And we also augmented that with the Cook's thesaurus, and it has a very large catalog of ingredients. And on top of that, if you look at food.com, recipe will have a bunch of ingredients, but it's very rarely, or it's not actually uniform to find nutrient information related to a recipe. Some recipe sites will have nutrient information, some won't. So we wanted to harmonize, have a kind of a standard interface for our food recipes. So what we did was we tapped into the USDA's nutrient database, and that has over 8,000 natural food products like apple, and also 400,000 branded food items. So it's like a bag of Lay's chips packet. And each of these food items have over 46 measured nutrients. These are macro and micro ingredients, nutrients. And then of course we leverage food ontology. Maybe some of you in the audience have used it. It's a field to fork ontology. And it's a very, thoroughly it's a very thorough, vocabulary for foodstuffs. So we leverage the food ontology as well. So what are some challenges? Again, I'm preaching to the choir here. So there are problems in consistency. Some recipes have kilograms, some have pounds, and non-standard units are measured to taste as needed. A few shakes. How do we actually capture the amount, complicated units. So it's like, fraction of something and different ambiguous names, the same concept, like pancake, cupcake, hot cake, they're all the same thing. And it's very hard to map all those things. And accuracy. So we were harmonizing different recipe, sources, and we could find same recipe in multiple sources, and we found these alignment problems. So that was also a problem. Spellings, spelling errors, incomplete data. So missing units was a big problem because most recipe sites they have stuff without numbers without any unit. So we had to do some guesswork, and then unnecessary information. So we do the entity extraction, and we find this ingredient called black beans from the stove, as well as black beans or beans. So figuring out what that means was problematic. And then completeness. So food knowledge continues to evolve, and that's the stage we are at right now, because we're trying to build the next version of the FoodKG. Then another challenge. This is both a challenge and a blessing. So food on, if you have worked with it, it's very dense, and it has a lot of information. So navigating the food on specificity was a problem. For example, if you wanted to look up the egg as a product, so there's egg food product, and you have to go down to figure out the hen product, and then there's this part of animal and egg in another category, right? So which categorization is the right one was it's not a big challenge, but it has way too much information than our food knowledge graph requires. So sometimes it's actually a better thing, because more information is actually better than lack of information. All right, so let me briefly talk about the construction. So we intentionally decided to keep the conceptual ontology model kind of flat, so that we can integrate things quite easily. So this is the full ontological view of our FoodKG. Of course, each of these classes have millions of instances. So just to give an example, we have something like a recipe. It has ingredient and ingredient. So this is the most queried triple in our knowledge graph, as you can imagine. And then we have other various data type attributes. If you take something like food characteristic, because we are trying to recommend certain food items, so people might have certain preferences for foods. So we have those characteristics encoded as well, and we extract those things from. Is it off? Oh, it fell down. That's funny. Okay. All right. So yeah, so food characteristics are there, and then user preferences again, maybe somebody has an allergic reaction, they don't dislike something, right? So we try to capture all those things in the ontology as well. And then food on imports. So I mentioned food on is massive, so we decided to just extract food product by organism category, and this has maybe I'll just hold it, or if you can hear me. Okay. Right. So we extracted this very food product by organism, and then we have mappings to those concepts in food on. Right. So with respect to constructing the knowledge graph, the first big step was mapping the nutrients, and for that we leveraged the semantic data dictionary approach. So I'm looking at Soib, but Sabir was the main person. So Sabir looks exactly like him. So Deborah, this project came from Deborah's group. So we leveraged a semantic data dictionary because the USDA ingredients are in a relational format, and it's quite easy to convert those relational information into triple format. And we again we kept where things are coming from. I mentioned provenance is a very important thing, and of course we used tools like Ontofox as well. And then for keeping provenance, we used the Nano publication standard. So if you're not familiar with the Nano publication standard, so basically there's something called an assertion graph, and a provenance graph, and a publication info graph. These are subgraphs. So the assertion graph will have an ingredient. Recipe has this particular ingredient, and then the ingredient will have these nutrients. So we are doing those kinds of merging of various information, And then the provenance information will have where is this recipe coming from. We record the URL of that. And then also the nutrient information from USDA. And for the publication information, who did what. So in our knowledge graph construction case, we have this linker, which is an automated process. So the nano publication information will contain this assertion was made by this linker. But it's quite possible that this is done by a human. So I'll talk about this when I go to the incentive part. So it's quite possible that a human will come and say, okay, here's a new recipe. I'm making this assertion. The provenance is basically, I found this information from such and such source, and the publication information contains the humans, contact information and name and whatnot, for attribution and other, kinds of information, or like kinds of provenance related information. Okay, so now let me talk about the applications. So, we created this food bot. So in this food bot, and there's a demo if you want to take a look, you can ask a question and then it will provide some answers. So that person earlier, like, Jennifer, like, maybe, she wants to find a good breakfast with eggs, and the bot will provide this information. Now, one big thing we do behind the scenes is that we personalize the knowledge. So the person's personal health knowledge graph, Jennifer's FoodKG will contain that she's 35 years old and is a female. But if another person with a different FoodKG asks the same question, so in this case, like, this is a 65-year-old male who's diabetic, our Heals food bot will provide food options with lower glycemic index so that they can be, it's more health conscious. So we provide this personalization behind the scenes. So this is what happens, behind the food Heals food bot of the Heals project. So when a user asks a question, we have this expansion, query expansion. So in addition to the question, so this is like, similar to, providing context in, the KG or like LLM-based applications. But we do this in a semi-structured way. So not only are we putting in the user's, question, we also provide like, users' preferences, their health conditions. And then we have this knowledge-based Q&A, which is powered by this method called bidirectional attention networks, or BAMNet. So this is kind of like an LSTM method. I've listed the paper here, so we are leveraging that method to do the Q&A. And then we query from the FoodKG and provide the answer. And in terms of the dialogue generation, so this was done prior to LLM. So we leveraged the IBM Watson dialogue flow. So there you had to identify intents and entities, and then we have this dialogue flow. And in the dialogue flow, you can have these hooks to like, additional knowledge graph or like, knowledge endpoints. And that's how we, kind of construct the answer and provide back to the user. And it's able to, maintain a dialogue flow, but not, as good as like, the current LLMs. And then another application that we have is this ingredient substitutions. So we, what we wanted to do is, so if we have a particular recipe, let's say rice, like, you are being health conscious and you want to find a, substitute for rice. So maybe you want the, the food bot to provide cauliflower rice as a substitution. So for this, we leverage implicit semantics and explicit semantics. So for implicit semantics, we leverage like embedding based, like word to vec kind of model, and see like which kind of recipes are in the similar similar to that particular recipe. And for explicit semantics, we leverage the food on hierarchical information, and there's a heuristic. So the heuristic, the dish heuristic, diet improvement ingredient substitution heuristic, leverages both the implicit and explicit semantics, and then ranks the results and provides to the user. So if you want more details about that particular work, I have the paper listed as well. All right, so in terms of extending the FoodKG and the applications, if there are any questions, feel free to ask. I think I'm going a little bit faster, but that's okay. I guess we can go to food. All right, so the types of questions that the FoodKG can answer. So there are these factoid type of questions. So we can ask, how much a certain nutrient is in a particular food item. So here, we're asking how much fat's that in butter salted, and the food recommender gives 51 point whatever grams of fat. Now this number might seem, very high. This is actually 100 grams. So this is what the USDA, provides. So USDA, all the food items, they are giving nutrients per 100 grams. If you take maybe spoonful of butter, which is what ChatGPT gives, it gives 7 grams or something. So that is, a spoon is 14 grams, and then it's half of that. So it kind of is aligned with what ChatGPT gives. And then we have comparison questions. So we can compare 2 different food items against one nutrient type. And then constraint questions is the most prominent type of questions that we have. So the previous example that we had, which Indian dish has chicken, onion, garlic, and then we have a bunch of these recipes. And more importantly, we have the link, which is derived from the provenance information. So some of the limitations of the FoodKG, or the here's Foodbot powered by the FoodKG, is that the range of questions in natural language is very constrained, because what we did was we had our retrieval engine is actually powered by Sparkle. So we had, in the previous examples, you probably saw how we are trying to match with FATSAT, which is the label for that in the food knowledge graph. If you ask saturated fat, sometimes it might not work perfectly, right? So there were certain quirks if you change the way you ask a question. So similar to that problem is the lexical gap, right? So the same question can be asked in multiple ways. And then the other problem is the answers retrieved from the Sparkle endpoint, they are heavily templated. So if you are a repeated user, you'll get the same kind of boring answer all the time. So so that was also something that we want to improve. So if you are wondering how do these types of questions compare with ChatGPT, current version of ChatGPT, if you ask which Indian dish has chicken, onion, garlic, it'll give a bunch of recipe suggestions like this. If you want to ask the same question from our FoodKG without the personalization, because the ChatGPT prompt did not have any personalization or a few short examples. So we have I think there are some similarities, but what you can notice is we have direct names, because we have the entities directly there in the FoodKG, and we have the link, which have all the aggregated nutrient information, everything connected. So what we are currently doing is we are improving the FoodKG inference with Retrieval-Augmented Generation. So luckily we have so many Sparkle queries. So I mentioned three different kinds of questions. So we have factoid type questions, we have comparison questions, and constraint questions. So for each type, we have hundreds of Sparkle query templates. And so what we've been doing is we are using those query templates as a few short examples to augment the retriever. And then we are retrieving some answers, and then of course the generator has to kind of put that in a nice way so that the users can see the answers in natural language. So we are, of course, there are questions with the token, sizes and whatnot. So this is something that we are actively working on, but we are off to a good start because we have that, base of several hundreds of Sparkle queries related to food retrieval.
1 minute left.
So this says 8 minutes. That's why I thought you had more time, but anyway. All right. Okay. So next up, I want to talk about the incentivization aspect. So this is a project that some of my students did. So they wanted to extend the FoodKG with baked goods. So the idea was people could submit food recipes, and then if they are novel, so we want to find something that's not currently in the FoodKG, they get a reward for submitting that particular recipe. And so they have this blockchain-based implementation. It's actually, there's working code there, so you can test it out if you have a MetaMask wallet. And then, this has this NFT kind of thing, so you submit a recipe. If it's there, other people have the rights to purchase your recipe. So this could be a way to incentivize good quality data entry to the FoodKG, or any KG for that matter. We also have this mechanism to deposit some money before submitting the recipe, because it's easy to have very random recipes submitted, right? So that it's completely novel, right? Something with you have a question? No?
Yeah. So is it the other user can buy the rights to publish the recipe? So is it like the recipe is unique?
It has to be unique. So we check if the submitted recipe is not there in the knowledge graph.
So it says other users, but can one user buy the rights for that specific recipe?
Right, yeah.
And then can they resell it?
Yes. So they have the ownership. Yeah, it's like any NFT. Nothing new in terms of the buying and selling aspect. All right, so I think I'm right on time. So this is a summary of my presentation. The project website is available if you want to contribute, if you want to collaborate with us. Please contact. And with that, I'll conclude my presentation, and happy to take any questions at the back.
Are you taking? Oh, sorry.
Thank you, Oshani. That was a great presentation, except you mentioned food. And it's almost lunchtime. No.
Are you taking any metrics about either how users rate recipes, or some other way of tracking how good they are?
Currently, no, but we could certainly extend that. Yes. So we had, another, group of people were looking at recipe reviews, but that part of the project were never incorporated into the FoodKG. But yeah, we can certainly include that. Yeah.
Will the company take a percentage of the sales?
Yeah.
Excuse me, sorry, we're taking a question here. Yeah.
Out of curiosity, what food or food group was the most difficult to model, or have the most edge cases? Just what was the most difficult part of modeling all this data?
I can give so many examples. So one big problem we had was, remember USDA has these branded product items. So the natural food items are 8,000, branded products are 400,000. So if I were to search for something like apple juice, we get baby food apple juice, baby food something. So there are so many varieties of food. So for edge cases, yeah, I think not many people would use the FoodKG for baby food, but we were retrieving too many baby food items, unfortunately.
Are you doing any kind of modeling for the preparation of the recipe, not just the ingredients, but how is it prepared?
Yeah, so actually the recipe 1M dataset has the steps. And in fact, I believe Sola had the flow graph work. So another, one of Deborah's students who actually graduated, he modeled the flow graph for how, actually, I'm not sure about the details, but in the FoodKG, we don't have recipe steps, but there's some concurrent work that we could easily incorporate.
Any other questions?
So FoodKG seems like an application for well-fed people, right? NSF has a track in the Convergence Accelerator on food and nutrition security. I was curious if you knew about that and the projects that are looking at various sort of food-related issues that are on the nutrition security side.
I haven't personally looked at it, but I'm more than happy to take a look and collaborate if there are opportunities.
In that case, I'm from NSF, so we will certainly want to connect you to those projects. Okay, we should talk.
Any other questions?
Hi, I'm just curious about the provenance information you mentioned. So did you see or have you encountered any applications or implementation using the provenance, maybe like tracking, I don't know, confidence score when answering, you know, the question, something like that? Have you?
Right. Well, in the recommendation engine, we weren't using the provenance information, but it could be possible that a human curated one to have a higher importance than the linker, right? Because it's vetted by an actual human. So it's something that we can incorporate. We currently don't use provenance information in the ranking. It's only like the similarity, the semantic similarity to the user's question. But we provide the provenance information so that the user can vet, this is, from a good source.
Any other questions? I'd really like to thank all of the speakers. I apologize. I wasn't told that I was going to be the moderator for this session, for this track. But thank you, Oshani. Thank you, Armin, Talanka. Thank you very much. I apologize again. And we had we had two great presentations that I caught. And I know I missed that first one, which I really wanted to attend. Was that you? I'm sorry. You know what? I really wanted to attend that. And I came running up and then they dragged me back. But anyway, any questions? It's lunchtime. I know, so grab the speakers, talk to them. Thank you again to the audience.